Good morning, everybody. Hope everyone's doing all right. Hopefully you have been getting my videos each day this week and getting the assignment. Today we're just moving on to the beginning of a new lesson, 3.2, factoring special products of polynomials. So we've been talking about factoring all week, so today we're just going to look at special products and how to factor those. So we're going to start off by factoring a difference of squares. So in order for us to do this, the degree of our polynomial must be 2, so it must be a quadratic. The past few days, for us to be able to factor, it needed to be a trinomial. But for today, for this special case, the difference of squares, we need it to be a binomial, not a trinomial. So we need it to be a quadratic, aka have a degree of 2. We need it to be a binomial, have 2 terms. And we must be able to take the square root of our a value and our c value. So our perfect squares are going to come into play here. So 4, 9, 16, 25, so on and so forth. It needs to be one of my perfect squares so that I can take the square root of it. So it needs to be in this form right here, ax squared minus c. And like this says, this is another condition that needs to be met. That must be a minus sign. If that's a plus sign, I can't use this difference of squares rule. So let's look at some more of these steps to factoring success. So these are just the 3 steps we follow to factor a difference of squares. Step 1, take the square root of the first term and put it into your first parenthesis spot. Number 2, take the square root of the last term and put it into your second parenthesis spot. And then step number 3, make 1 a plus sign and make 1 a minus sign. And so let's look at this example down here to get a little bit better picture of this. It says factor 81x squared minus 36. So let's see if it meets all my conditions. I need to ask myself, is the degree of this polynomial 2, aka is this a quadratic? Yes, it is. The highest exponent is a 2. Is the number of terms 2? Is it a binomial? Yes, this is a binomial. My first term is 81x squared, second term is 36. So it is a binomial. And then I must be able to take the square root of a and c. 81 is my a value. I can take the square root of that. 36 is my c value. I can take the square root of that. And I have a minus sign in the middle. So it meets all 4 of my conditions, so I can now use this rule. So step 1, I'm taking the square root of my first term. So I'm taking the square root of 81x squared. When I take the square root of 81x squared, that gives me 9x. So like on step 1, it says take the square root of the first term and put it into your first parenthesis spot. So that's what we did right here. Took the square root of 81x squared, which was 9x, and put 9x in both sets of my parentheses in the first slot. Step 2, I need to take the square root of my last term and put it into my second parenthesis spot. So I'm taking the square root of 36, which is 6. So I'm putting 6 into the second spot in each set of parentheses. Step 3, make 1 a plus sign and 1 a minus sign. That's what I'm doing right there. And so this would be me factoring 81x squared minus 36. And once again, to check our answer, we just FOIL it out. So 9x times 9x gives me 81x squared. 9x times negative 6 gives me negative 54x. 6 times 9x gives me positive 54x. 6 times negative 6 gives me negative 36. Combining my like terms and simplifying this, my x terms cancel each other out. So I get 81 x squared minus 36, which is my original problem. So I know that these two are my factors. So I feel like this is probably the easiest form to factor, because you just take the square root of two things and then put a plus or minus sign. So let's look at some more examples together. This is just another way of looking at it. If I have a squared minus b squared, it just turns into a plus b times a minus b, which is what we saw on the last slide. So let's look at letter A. We have x squared minus 25, and it wants me to factor it. So step one, it wants me to take the square root of my first term. So I'm taking the square root of x squared. I'm asking myself what number or variable times itself gives me that radicand, the number or variable under the radical. So x times itself gives me x squared. So the square root of x squared is x. So I'm putting x in the first slot of each set of parentheses. Step 2, I'm taking the square root of 25. Square root of 25 is 5, so I'm putting 5 in the second slot of each set of parentheses. Step 3, I make one a plus sign, one a minus sign. So here is x squared minus 25 factored. If I multiplied that out, FOILed it out, I'd get x squared minus 5x plus 5x minus 25. Those cancel out, so I'm left with x squared minus 25. So it checks out. Like I said, I hope this is in my opinion, this is the easiest form of factoring whenever they're in a difference of squares form. Hopefully you guys think so as well. Hopefully this is really easy for you all. Let's look at letter B. Once again, if something's not clicking, make sure you're asking me questions on Canvas, Remind, email, anything like that. I'll be happy to try to help you out as quickly as possible. Letter B. We have 4z squared minus 1. So step 1, I'm taking the square root of my first term. Square root of 4z squared just gives me 2z. So I'm putting 2z in the first spot of each set of parentheses. Step 2, take the square root of my second term. Square root of 1 is 1. So I'm putting 1 in the second slot of each set of parentheses. Step 3, make 1 a plus sign, 1 a minus sign. There's my two factors. If I multiplied it out, 2z times 2z gives me 4z squared. 2z times negative 1 gives me negative 2z. 1 times 2z is 2z. 1 times negative 1 is negative 1. That leaves me with 4z squared minus 1. So it checks out, and I know that 2z plus 1 and 2z minus 1 is my factored form of 4z squared minus 1. Like I said, hopefully that makes sense. If not, make sure you ask me some questions. Moving on to the next set of special products. We're looking at the perfect square trinomial pattern. So if I have a polynomial that takes this form, a squared plus 2ab plus b squared, then I can factor it into a plus b squared. So here's an example over here. X squared is just x to the second power. 9 is 3 to the second power. So this middle part would be 2 times my a value is x My b value is 3. So that'd give me x squared plus 6x plus 9, which is what I have right there. They broke it down the same way I just broke it down. I didn't realize that till just now. Sorry. But since it takes this form, I am able to just plug in my a value and my b value to a plus b squared, and there is my answer. So all we're really doing is identifying our a value and our b value and then plugging in. We have another one right here. Notice this one is plus plus. We have another one if it takes the form a squared minus 2ab plus b squared, then it would become a minus b squared. So it's the same concept, finding our a value, finding our b value, plugging in to a minus b squared, and in this case we get x minus 3 squared. So let's look at an example real quick. Factor each polynomial. So my a value in this case would just be, a value in this case would just be n. My b value would be not 16, I apologize. Square root of 16, which would be 4. It is plus plus, so I know I'm going to have something plus something squared. My a value is n, so I plug that in the a spot. My b value is 4, plug that in the b spot, and there's my answer. N plus 4 squared. And I can always check my work. If I rewrote n plus 4 squared, it would be n plus 4 times n plus 4. Foiling that out gives me n squared plus 4n plus 4n plus 16, which becomes n squared plus 8n plus 16. So you can use these formulas if you want, but let's look at it a different way. So we're still on letter A. I could just factor this like I did the other day. Create my two sets of parentheses, fill in my variable, fill in my x puzzle. 16 would go up top, 8 would go downstairs. Fill in my signs into the set of parentheses, and then I'm solving my x puzzle. I'm looking for two factors that multiply, or two numbers that multiply to give me 16, and add to give me 8. Well, 4 times 4 gives me 16, and 4 plus 4 gives me 8. So I plug those in. I got n plus 4 times n plus 4, which I can rewrite as n plus 4 squared. So as you can see, I get the same answer I got earlier. So if you're more comfortable just using the method we used the other day, I am completely fine with that. I just wanted you to see this little method as well. So if you like the formulas, use the formulas. If you like this other method that we learned the other day, use that method. Let's look at letter B. Let's do the first method that we learned today, where we're using our perfect square trinomials pattern, a minus b squared. I know it's going to be a minus b squared because it has a minus and a plus instead of a plus plus. So my a value would be 2x in this case. Just taking the square root of 4x squared and give me 2x. My b value would be taking the square root of 9, which is 3. And so I get 2x minus 3 squared, and there'd be my answer. Once again, if I multiplied this out, 2x minus 3 times 2x minus 3, get 4x squared minus 6x plus 9. Combining my like terms, I'd get 4x squared minus 12x plus 9. So it checks out. So once again, there's our formula method. Just taking the square root of your a, taking the square root of your b, and that's your a and your b values. And then plugging those in to a minus b squared or a plus b squared, depending on the signs. Once again, though, I don't have to do it that way. In this case, I don't have just a 1 in front of my x squared term. I have a number. So I first need to see if there's any common factors I can factor out between my three terms. 4x squared, 12x, and 9 do not have any common factors, so I can't factor out anything. So I'm going to have to use slide and divide in this case. Take my 4, multiply it by my 9. That gives me 36. So I'd get x squared minus 12x plus 36. And now I'm factoring like normal. 2 sets of parentheses with my variable. My signs are minus plus, so I know my signs are going to be minus minus. And now I'm creating my x puzzle. 36 goes up top. Negative 12 goes downstairs. Looking for factors, numbers that multiply to give me 36. Add to give me negative 12. In this case, that'd be negative 6 and negative 6. So I'd fill those into my parentheses. And then don't forget, you have to divide by the number you slid over earlier. So that'd be 4 in this case. So I'm dividing both of my 6's by 4. That would give me x minus 3 over 2 when I reduce my fractions times x minus 3 over 2. Do your bottoms up for both of them. That'd give me 3x minus 2 times 3x minus 2. Or 3x minus 2 squared. So once again, you get the same exact answer. Whichever method you prefer, I'm okay if you use. If you want to factor like normal, that's fine. Or if you want to use these formulas, that's fine as well. Once again, if you have any questions, let me know. Today's assignment is page 113, numbers 3 through 8 all, and 15 through 22 all. It's only about 14 problems. So if you can get this knocked out today, that'd be great. If you can't get it knocked out today, I am going to make the due date the Tuesday after Thanksgiving break. That way you don't really have to worry about homework over the break. I don't want to be that teacher. I want you to enjoy your break with your families. If you're getting together with your families, or if your family's deciding to stay home because of COVID, I want you to just worry about staying safe with your family. I don't want you to have to worry about doing the homework over the break. So the due date will be Tuesday. What is that today? Due Tuesday. That would actually be December 1st on Canvas. That way you can get some of it knocked out today or all of it knocked out today. But if you don't finish it, don't worry about it over the break. You can finish it that Monday after the break. So this will be due Tuesday, December 1st on Canvas. Like I said, if you guys have any questions, please let me know. I want you guys to really enjoy your break. Don't necessarily think about school a whole lot unless you have a bunch of missing work. Then you need to worry about it, obviously. Get that missing work done and turned in. Thanksgiving break's a great opportunity to do it. So get it knocked out. Y'all have a great break. Maybe we'll see you after Thanksgiving break in person, maybe not. But y'all just stay safe. Y'all have a good evening.